Welcome in, folks, for this Tuesday edition of Weather Talk here on KETK Plus. We've got a great guest with us today. He is a meteorologist at the Columbia Scientific Balloon Facility in Palestine, Texas, where he's been for the past 21 years and oversees weather forecast for the balloon program. He also has experience as a severe weather coordinator at an NBC weather office. He also has experience at the Weather Channel and was a weather producer for quite some time at CNN. He is Ross Hayes. So welcome on in, Ross. How are you doing today?
Good, thank you.
So, Ross, how did you catch the weather bug? I know you came from the Gulf Coast. You saw quite a few hurricanes there. I remember when I was young, we saw quite a few hurricanes along the southeast Texas coast. One of the ones that comes to mind was Rita, and then earlier that year, it was Hurricane Katrina. I understand your interest in weather came from similar storms.
Yes, because growing up on the beaches of the Gulf Coast, like in the sea breeze in the afternoons in the summertime, you'd see thunderstorms develop daily and start moving in. Got to be of interest. Okay, why are these thunderstorms developing daily and coming by? Last only 20 minutes and be done, and see that. And then having to sleep on the floor as a child when Hurricane Betsy was coming in. Grew up seeing all this activity and things happening. It got me more and more interested in meteorology, but when I went to college, I really didn't know meteorology would be a career.
Yeah, I mean, it's one of those interesting things where it seems like for a lot of meteorologists, it's either one event or a collection of events that leads to your interest in meteorology, and then you're kind of called or you're kind of pulled to the career at some point. I remember for me, it was Hurricane Katrina earlier. It was in 2005, I believe, and just watching some of the live coverage of that. I mean, it was just absolutely incredible just to see the power of the storm and, the unfortunate damage that it could cause. So take me through your criminal justice days at Tulane University and how you got involved with meteorology there.
Well, I got a department of the athletics, got a full scholarship to be an equipment manager with the football team at Tulane. And I always enjoyed criminal justice. My grandmother said it was in my blood because I had several ancestors who were in law enforcement. But I studied the criminal justice program. But also in New Orleans, there was a local American Meteorological Society chapter that I joined. So I started going to the meetings there just of interest of what was taking place and what went on behind the scenes. And people that had careers in meteorology that were members of this association. So got to work and see and feel what was going on more and more and became close friends with several members of the AMS there. And they led me down the track.
Yeah, for sure. And it was a long track, especially going from New Orleans up to Vermont, as I understand it.
Yes, because one of the New Orleans television meteorologists, he recommended Linden State College, a small school in northern Vermont, just 35 miles from Canada, because it had a good program in synoptics for forecasting and analyzing the weather, not just theoretical meteorology as many programs have. So that intrigued me, and also I'd always been in the South and on the Gulf Coast, so that gave me an opportunity to go up and feel the seasons, be in the snow when it happened.
Yeah, they have quite a few snow storms up there in the Northeast. You got the nor'easters, and then just other winter storms that occur up there, and yeah, it's pretty rough winter. I'm glad you're back down here in the South.
I've had my many experiences in winter. I like the warmer climate better. It was interesting to learn there, though.
Yes, absolutely. And winter storms are really cool to forecast as well. I mean, I would say, Ross, they're a lot harder to forecast down here than they are up north because you kind of know you're going to get slammed by snow.
Yeah, because you're totally polar climate, cold air all the way up the atmosphere. We're here, it's borderline. It might be cold at the surface, but still warm above the surface. More often here, you're living on the edge, per se.
Yeah, and I know we have viewers, they're right on the line of 4 inches of snow or just a bunch of rain. And that always makes it interesting in the Facebook comments.
Yeah.
But yeah, so that's cool. So talk to me about your career in meteorology. Where did you get started, once you were up there in Vermont, and where did it lead you to?
Well, when I was studying in Vermont, the chairman of the meteorology department at that time, he left to become the first chief of operations when the Weather Channel went on the air. Joe DeLeo was his name, and he brought 11 of us with him. We followed him down there to work with the Weather Channel right when they went into operation. And my job at the first year there was to do overnights, being severe weather coordinator. Because you know how when there's a warning, how it pops up on the screen and crawls? Well, in those days, it was computerized, but you had to manually put in what state and zone number that warning was in so they could see their warnings. And also would draw where there were watches and warnings around the U.S., a map to use for on the air. And they also had me doing aviation meteorology, forecast maps and things too for turbulence and where the jet stream was and things to show in the early mornings there.
Mm-hmm. So how would you say, comparing today's Weather Channel to the Weather Channel back then, how would you compare the two? What has changed?
Well, it's become a little more talking heads, I guess you'd say, and they also have other programs too now in their daily program, not just weather 24/7 as they did in the early years. So there has been some mellowing about. There is the graphics and good information they do still provide, though, and they still send their people out to the edge of the hurricanes and live and covering it. Yeah.
Mm-hmm. Yeah, no, the reason I asked you that was my grandparents, they always had the Weather Channel on.
Oh, yeah.
That's how they got their weather.
Sure.
They didn't care about the local meteorologist,
Yeah.
but they always had Jim Cantori on the Weather Channel. And I remember my grandpa was kind of annoyed because, they had all those documentaries on the storms. I like the documentaries, but that's just me. But he said the founder of the Weather Channel at that time had said it was going to be 24/7 forecasting, and that's what
John Coleman pushed it hard to have that. Yeah.
So yeah, and he was a bit frustrated with that, but again, I remember just being up there with my grandparents and always watching the Weather Channel. And I understand for the past, what was it, 21 years you've been with the NASA balloon program?
Yes.
Or the Columbia Scientific Balloon Facility, rather?
After I went to CNN and did all their weather maps and graphics for 20 years, and they went through multiple corporate takeovers, then I found this job with an AMS post for new jobs in East Texas. I said, okay. I'd never heard anything about it before then, the balloon program at NASA. But we came down and it was nice to meet the man, because the man who was site manager at the time, too, he had been a meteorologist. So he knew what we were doing and what was going on. It was nice meeting with him. That got me into East Texas and the balloon program. And one thing, too, just to note, going to work with that group, you had to first pass an Antarctica physical.
An Antarctica physical?
Yeah,
what goes into an Antarctica physical?
Well, that's required every year. You run on the treadmill. They take your blood pressure. They look at your teeth. Because I had to have my wisdom teeth removed the first year. That was their requirement. Now, I didn't have any problems with them, and the dentist really didn't think there was anything wrong, but that was their requirement because they don't want anything to happen and go wrong when you're in Antarctica, miles away from significant medical care.
Yeah, I can imagine that would be pretty rough if, God forbid, there was a medical emergency down there. So, yeah, that makes a lot of sense. Now, correct me if I'm wrong, Ross, you're specifically into forecasting for the balloon launches. Is that correct?
Yes, sir. I tell them when the weather is going to be acceptable to take those big balloons out and lay them on the ground and launch, because they're so large, you don't want to just run out in and out each day and put the balloon out. It doesn't that easy. It takes hours to pick a direction you want that balloon to be laid out, take the balloon out of the box and lay it out. Then inflation of one of those takes 2 hours as well. So we have to watch and be careful that nothing is going to interfere with that. There won't be an increase in the wind during that time frame or shift in direction, not to mention precipitation or anything else that could impact.
Mm-hmm. So you talk about, just the different elements of the weather and how long you guys are having to forecast for. But I understand it's a bit different, than your regular run-of-the-mill operational forecasting, let's say for the ground level, what folks do at the National Weather Service, what I do here at the TV station, because we are forecasting in the troposphere. That is where most of the weather occurs. Yeah. But in your notes that I have here, you're forecasting for the stratosphere as well. So just talk about what you are forecasting for in both the troposphere and the stratosphere and how that relates to launching the balloon.
Well, one thing, the trope, the coldest temperature in the atmosphere, that's always provided to the flight director and information, because we want to know when a balloon is ascending, how high will have to ascend before it reaches that coldest point because it slows down when it goes through that coldest layer of air. Then it goes on up and ascends and starts increasing its speed of ascent to reach its float level, which is usually most of balloons, it's around 120,000 feet. And we want to know in advance which way is the wind going to be blowing from and towards when we do have a balloon floating there. So they'll be floating the proper direction. And we'll get their amount of hours. The science tells us in advance they need to be floating above this altitude for X number of days or hours, or whatever, to carry out their science. So we want to make sure they'll check all the guidelines to see that the forecast winds and the float levels of the atmosphere are proper for them to have their science met.
And what tools are you forecasting with?
Well, one thing to check the weather balloons that are sent out around the world that go up into the stratosphere, because most of the balloons do make it up above 100,000 feet that the Weather Service releases twice a day. And then that's put in with model guidance as well to see how the stratosphere is looking, if there are any little strange anomalies in wind speed directions or little pressure changes. Because, for instance, we go down to Antarctica each year to launch balloons. And when we're down there, when we first get down there, it's still the polar vortex, as you say, you know, in the Antarctic season. So the wind's blowing the opposite direction of the direction we want it blowing. So we wait for that wind to drop off, and then the southern high pressure system builds up in the upper levels of the atmosphere, and the float direction's set up where we launch balloons that can go circle Antarctica for 30 to 50 days and just go round and round. So that's why we wait for that moment to hit. Have the balloon science is tested and ready, and we start telling them when to look for the start date. And we also do launch what we call tracking balloons to go into the stratosphere to make sure the wind speed and direction is acceptable in a lot of these, especially these long flights down there.
You know, Ross, and I was surprised when I watched the documentary you sent me on this program of just how large these balloons were.
Yes.
You know, I thought the balloons that were launched by the National Weather Service were pretty large, you know, and we use those quite a bit, you know, to figure out if there's a cap in place, if there's going to be severe weather, you know, just what some of the different elements and lifted indices are for severe weather. But just talk about how large these NASA balloons are.
The primary work balloon is 40 million cubic feet, and it stands 900 feet tall when it's being inflated. And I say the amount of acres, there's about 30 acres of material that make up this balloon. It's the same kind of material as your plastic sandwich bags are. They lay the balloon out, and there is assembled up here in northeast Texas in Sulphur Springs. It's a building there where it's 700 feet long, where the balloon is put in pieces and sections and assembled together, then brought down to us in the crate box to take where we need it to be launched. But the balloons, it's the same size as, say, the Dallas Cowboys Dome Stadium.
Yeah, that is kind of funny because the nickname for the Dallas Cowboys Stadium is the Death Star, you know, and apparently you guys launch these quite often during the course of the year. But what kind of data are y'all getting from these balloons?
Well, 80% of the science that we send up is astrophysics, looking out into space, because we take these balloons up through 97% of the atmosphere. So it's like they're in the attic of the atmosphere, looking right out without clouds or any kind of lighting or any problems and issues. And we do have every now and then a larger balloon that will take them through 99% of the atmosphere, floating at 159,000 feet. So we do have that on special occasions for these specific balloons that want to be that high up, for their science to be carried out. But we also, as well, do special things for NASA and other things. We've tested the weather satellites a couple of times. Where we have a balloon up floating to measure what the temperatures and winds are at certain altitudes. At the same time, the weather satellite is seeing if it's accurate. And that ER2, what used to be the U2, they have one of those up also at the same time to test. Every 5 years, they like to test and make sure the weather satellites, what they're estimating, temperature, moisture, and winds, is accurate. So we've done that for them before. And we've also launched a rocket from underneath our balloon out in Hawaii at the Pacific Missile Range. That was to test the reentry system, put a laboratory on Mars. So we had the rocket take to 107,000 feet, release it from the balloon. The rocket then blasts into space and then re-enters. And so they could test, and it landed in the ocean. They recovered it out there. That was just the idea of that.
And what are the entities that take in this data? What are they doing with it? What is NASA going to do with it? And looking at the future, what could come from all this data?
Well, one thing they're looking at what kind of electromagnetic rays and sounds are coming into the edge of the atmosphere. What's going on with the sun? How is it up and down? What are the sunspot cycles and things? Getting more information on that. And also, too, one place every now and then we have to go to Australia, to Alice Springs, because we have those that want to look at what is the history of the galaxy we're in. Because to see the center of our galaxy, you know how the Earth is tilted. We have to go to 24 degrees south latitude, take something up to see the center of the galaxy. We can see the galaxy here, but because of the tilt of the Earth, we can't see the center. So we've launched balloons down there specifically so they can study the composition and what the origins of our galaxy were like.
Wow, that's really cool. And what have you all discovered since this program has been live?
Well, I know there's been 1 year the Nobel Prize in Physics was awarded to one of the science groups that launched with us. I think that was in 2004 that took place. Also, too, just to note, we have checked the Mars rover's parachutes. That was my first project, to make sure their parachute systems would deploy and operate properly, because the current Mars rovers driving around up there are larger in weight than the previous generation ones, and they had those in kind of bouncing ball type systems. So that's one thing we've done that for NASA as well.
Mm-hmm. Sounds like it worked because you still have a job there.
Yes, we did 3 tests and they were good.
Mm-hmm. And what is the future of the program looking like? I know these are very interesting times, especially for weather balloon programs, not only with y'all, but for the National Weather Service as well. So what are things looking like there?
Well, at current, for the next year's budget, there is no money been placed for the scientific balloon program. So several of us were trying to contact our representatives and senators to say this is a very good economical program. Because if you look at perspective, one rocket launch is multiple years budget for us. It used to be 7 years. I think it's a little less now with what's taking place. But it's a good program, and there's these students and people that are graduate assistants that come work with these science groups, and now they're doing the science themselves. We've seen that happen. So there's good education in science as well as the research and what's taking place. And one of the first projects I know of too, before they ever sent up the big satellite that has the telescope orbiting around, well, before they sent that telescope up, we had to test one in Palestine, Texas, to make sure that they could zoom it, they could use it, and have good resolution with the telescope before it was launched. And we were the test vehicle for that. So we have worked in several different elements and areas for NASA because we are economical in a sense. And although that's helium that we use to inflate the balloons and have them go up, and most of our helium comes from just outside of Amarillo, Texas.
Yeah, and I will say the data that comes from these weather balloons, as Ross has just stated here, it is very, very important. It helps us get data for big, severe weather days. It helps improve the overall forecast models. And overall, it's just a great thing to have and a great tool to have. And as Ross mentioned, it's very economical. And Ross, why is it important for the people of Anderson County? How many people does this program employ? And, what future discoveries may we make?
Well, one thing, we're a very small part of NASA. There's 76 of us, I believe, on staff, and so it's not a large area. A lot of them call us NASA's little secret because we're just a small program, but we're good, economical, and get things done and continue to carry out. And one thing, all the science we launch is recovered, and those payloads can be launched again. They can put bigger computers and stuff and continue doing their same research over several years that way. Because, if they go up on a rocket, they burn up on reentry, unless they have the special reentry system, which costs hundreds of millions more. So that's why we're a good economical system.
So go ahead and take me through the day of a launch. What's happening early in the morning, and what are you all observing throughout the day?
Well,
and talk about a successful launch date.
Well, we have a meeting the day before, make sure the science group is ready. and we ask science how much time will they need in advance of launching to have their scientific payloads ready to take out on the pad. So we plan our pickup in time for that, start coming in, and I get in usually 2 hours before they do. And there's other meteorologists too in the program as well that do the same. Check radar, check what the numerical guidance is saying, go out and run a pilot balloon just to see what the low-level wind speed and direction is, to show the launch team when they arrive, okay, this is what it's looking like, and it's going in agreement with the computer guidance, so things are acceptable. That way we know when to go out, and also what direction do they want to lay the balloon out on the ground, too. They can start looking at that direction from those first pilot balloons that we launched in the morning, and do synoptic analysis also to make sure it doesn't look like there's a front or something coming that would shift the wind speed and direction and change everything, increase. And we keep tracks and running tabs on that, so I'm running pilot balloons usually hourly until we get up near time to lay the balloon down. Then we start going half hourly on that. Science and then tells us whenever everything's ready, and then we start, and it usually takes like about 2 hours to have inflation of one of the big balloons gone through. And then as it's inflating, do a couple more pilot balloons just to make sure, because that way the crew chief too, he wants to know how is it going to look when it's let loose and starts ascending. So he wants to look at that at the man. So there's a last minute pilot balloon also give that information to him, then they can proceed, because we have payload vehicle that can hold our 8,000-pound science payload from it, and he's down from where the balloon is laid out, and the balloon is released and comes up over the top of the payload. And then there's 3 guys on the payload vehicle, and when they see it starting to tug it, as it's getting ready to inflate, they release that payload, and it can start its ascent. And like I said, 8,000 pounds is the weight of our largest payload we send up, about the size of a 4-door pickup truck.
There we go. That could be the new Ford commercial,
Yeah.
maybe. I just kid y'all. What do the conditions have to look like, during the launch window? Because I know it's a very delicate window. Winds have to be, a certain direction. Winds changing with height, that could be a problem. So ideal launch conditions, go.
Well, ideally, we want, say, 0 to 3 knots on the surface. The low-level winds between 500 and 1,000 feet. 5 to 6 knots if you want, because we don't want them over 12 knots, because that gets too much for those balloons to be pulling and tugging. And then we make sure everything's good in the same direction. We don't want cross directions and reverse directions for all these wind speeds. Now, sometimes we can have light and variable on the surface and just depend on what the low-level winds are in those situations. We'll make sure that's good and everything looks good for them to go up. And some of these don't want to have lots of cloud cover, too, when we're inflating. It doesn't matter on all the balloons, but those that have telescopes and things, they don't want that condensation to form on there, because it can freeze and become icy as it ascends, because it's not going to get that much warmer after it goes through the trope. So that's one thing with some of our science. It's all depending on what we're using and what we're ascending with at that time. Make sure it's good, nice weather for that.
Yeah, and I've always, you do have a bit of an aviation background as well, with the aviation maps you were drawing earlier in your life. What is that like? I mean, are you guys doing some sort of de-icing process to the balloons themselves?
No, we don't have that capability. We want to make sure there isn't going to be significant icing on the balloon, no.
Gotcha.
Now, in Antarctica, we've seen ice fog form as well, but the top of the balloon's above the ice fog we had one time down there. So,
yeah, I can only imagine, because it, like I said before, it's just such a delicate window, to get these things up in the air. But man, when they're successful, these are reliable measurements, and like you said, very cost effective. What are the figures? What are the figures, would you say, Ross, between a rocket launch and launching one of these weather balloons?
like I said, a rocket launch itself costs $200 million, give or take. And that was one reason we launched that rocket in Hawaii, so we wouldn't have the first stage for them to do the test. That saved them 40 or 60 million, they said. So our balloons are just 1 or 2 million. The balloon itself is like $200,000 plus the cost of the helium, inflation, and the science. And we do recover the science, so like I said, most of the time the science is reused. That's why I'm saying one rocket launch is equal to multiple years of our program. Like it used to be 7 years, and it's probably a few less, maybe 4 years now. So there is much more economical in launching a balloon and doing the science that way.
Yeah. Absolutely. And just from your meteorological standpoint, where do you think everything is going to be, within 5 to 10 years, the state of operational forecasting and, what you do with space forecasting budgets aside?
Well, I think they, especially in the short term, need to continue doing weather balloons because those to me are critical because all of that data is put into the computer guidance worldwide. Everybody around the world, all the countries, they launch their weather balloons the same time as we do here. So that all that information is sent out to the different places where forecast guidance goes in the computers and initializes. So they have same data just to make sure what's going on in the atmosphere, and that can help in the accuracy of the forecasting. Because going away from that, you're starting to lose that accuracy.
Mm-hmm. Yeah, I mean, and I've seen some charts online, I think more specifically the global forecast model earlier this year, it seems like it's less accurate than it was at the beginning of the year. And of course, that comes from different sources. I won't get into that. But, a lot of that data has been missing from a lot of local National Weather Service office. They do that to a smaller degree, but the frequency of their balloon launches is probably quite a bit more than what you guys do, but that data is very important. Last thing I'll ask you, Ross, is give me just one of your most memorable moments as a meteorologist for one of these balloon launches.
Well, it probably would be in Arctic Sweden. We were going out, and the pilot balloons that morning, it was 38 and it dropped to 42 below zero while we were there. And the pilot balloon, now the first one to launch it, went 100 feet after I released it, but then it just exploded. And just because the air was so cold. And the trope that day was minus 74 Celsius. And I mean, the balloon's just amazing. They told me, and we had to go inside every 20 minutes so we wouldn't hurt our lungs and freeze them because it was so cold that morning. I mean, we were doing launches into the polar vortex is what that study was for. We had to wait for it to come around to Arctic Sweden, launch the balloon in it, but that was the coldest air we'd ever launched a balloon in, was that weather. And to not even have the bobbles work, the crew chief finally said, just go inside. You don't worry about it anymore because where we were, there is a tower, and on top of a small mountain, they call it Radar Hill, there were continuous weather observations. They felt that could support that balloon wind information-wise. But it was interesting to have all this happening where there was nothing you could do because it was so cold. It was popping your theodolite and pieball balloons.
Yeah, Ross, I remember when I was up in Montana, similar temperatures.
Yeah.
I think we were about 39 Fahrenheit below zero. And I wanted to be the kid and go out with a boiling thing of water and throw it out the front porch. And it froze.
Yeah,
froze
I know
before it
one
hit
of
the
our
ground.
guys did that morning. And that was one thing, too. We only had 43 minutes of daylight when we were at that time of year there, too. So it was just dark all day. That was I like 24 hours of daylight much better when we go to summer seasons in Antarctica.
And how much helium does it require to fill one of these things up?
Well, 2 tractor trailers for one of the big balloons.
Oh, my goodness.
Yeah.
2 tractor trailers. That is a lot of helium.
And then we send it down a year in advance to Antarctica. So it's stored in containers down there.
And talk a little bit about those trips to Antarctica. What all have you gotten to experience? Because it sounds like you guys are launching these things all over the world for various scientific reasons.
In Antarctica, it's a yearly event down there. We go every year. We go down. We have to go to New Zealand. And the U.S. Air Force has cargo planes that fly out of Christchurch, New Zealand. They drop you off on the ice in Antarctica, and they fly straight back. And it has to be VFR down there, visual flight rules. There's no radars. There's no landing lights. It's just landing on ice and snow. So they take you down. They make sure everything's good, give you a window to go because we've had to what they call a boomerang, flying down there and had to turn back because ground fog formed on the ice. So we had to fly back to New Zealand. We couldn't go in. So it's very critical in the time and getting in and out of there. And the plane doesn't stay there. It just drops you on the ice and unloads, and it heads back to New Zealand.
Yeah.
So then you're there, and they are dormitories for us to stay in there. And then we're in a field camp that's out on the ice shelf where we do the ballooning from.
Hmm. And how long are you guys down there for?
Usually 6 weeks, and some of our pre-team guys, they're down there 8 weeks.
Wow. Yeah, and I remember, I think it was on social media or something, you were sharing a lot of photos of New Zealand, and I
Yes.
was like, man, this looks like an incredible place
That's
to go
beautiful.
visit.
And we also launch separately every other year in New Zealand so we can have balloons circle the globe without having any problems with the State Department. Because in the Southern Hemisphere, it's mostly ocean, so all the balloon will fly over is Chile and Argentina, and we have agreements with them as well as agreement to terminate the balloons over their countries as well when they fly. So that's why they can just go round and round the world when launched from New Zealand.
Yeah, I imagine there are a lot of different airspaces I'm sure y'all are communicating with
yes.
down there, especially if it's circling Antarctica. So, I mean,
It's all scientists and science groups in Antarctica, so everybody's open and easygoing.
there we go.
And we turn the communications of a balloon over to the National Science Foundation and the U.S. Antarctic Program that's down there. So they handle most of the liaison work in there. Because we do try to get the balloon to come back onto the Ross Ice Shelf to terminate close to where we've launched it from. But there are other times where we've had to terminate in other places around Antarctica. But everybody's pretty good. The Terra Nova, the Italians, okay, come on, fly on in, and we'll help you go pick up the balloon and the payload and bring it in. And South Pole Station, every now and then, they've had to go out of, to launch out of there.
That's cool. Anything else you would like to add, Ross? I mean, you're one of our best weather watchers because you give us all those reports anytime it rains, and we greatly appreciate that because, as you know very well, in Anderson County, when we have a lot of rain, there's typically a lot of flooding.
Yeah, so it's good to have that information and guidance, and like I said, let the Weather Service know when there is something going on, because we're all living on the edge. Since Fort Worth, we're the farthest east county that they handle, or southeast, because the county, South Houston County, that's the Houston-Galveston office, and go over to Cherokee County, that's the Shreveport office. So it's tough to make sure they need to know that when something significant is going on there. Because a lot of times, I know they're going to need to population-wise focus on the Metroplex, but we're still out there,
Yeah, and just to note on what Ross is referring to, so the National Weather Service office in Fort Worth covers Anderson County, so you're shooting several thousand feet up into the atmosphere, and then on the other side, about the same distance from the National Weather Service office in Fort Worth is the National Weather Service office in Shreveport. They're also shooting several thousand feet up in the atmosphere from their radar side, so getting low-level data from our weather watchers is very, very important to give us an idea of what all is happening. Alrighty, Ross, we'll go ahead and wrap this up unless there's anything else you would like to add about the balloon program, your life, or, just anything else.
Well, it's great for science, education, and it's good continuous observation. It's good for East Texas. I hope it does get rebudgeted, or it has a budget to continue operations in the future.
Yep, absolutely. Yeah, I may have to write a letter to Representative Lance Gooden on that one.
Yes.
Because, again, folks, this is a very important program, and we can continue to learn, not only a lot about our Earth, but what's going up in space as well. And it's very supportive of many scientific operations, both here on Earth and beyond. So thank you for joining us, Ross. That is a lot of information. I'm going to have to go back through this interview just to digest everything because this is very scientific. It's a great learning opportunity for our audience, and it's a great learning opportunity for me as well. So thanks for coming in.
Thank you so much.